Assalamu alaikum guys, welcome back to my channel, and today in this video we will talk about one of the important topic which is actually almost anyone's problem, that how to select a best model for our data set. Because whenever we're working with the data science project or with the AI project, selecting a model, selecting a suitable model is one of the important thing to do, one of the main thing. So first of all, we'll import some libraries which are called import numpy as np, and we will also import pandas as pd. So here, first of all, I will upload the data set which I will use pd.read csv, and I will use the data. So the name of the dataset is actually about the commuter dataset, which means that we will use to predict the traffic volume based on the weather, based on the rain pH, based on the temperature, based on the wind direction, and based on all these features that are other than the traffic volume. So, for example, we will create a model in which we will have to predict that how many persons are currently in that road. So we will actually go with the air. We will actually first of all go with the air pollution index. Then we will enter the wind direction. We will enter all these things apart from traffic volume, then it will predict us traffic volume here. So here x is actually all the values that are other than traffic volume, and y is actually the predicted value which will need to predict. It is actually a traffic volume. So I hope you understand the problem. Now, if I think about the problem is a regression problem, which means you have to use the regression techniques here. So, first of all, I will randomly explain you something, and then we will move to forwards. So, first of all, whenever there is a regression problem, try to start with the linear regression, which is one of the basic model of machine learning, linear regression. So, first of all, we will import the linear regression is first of all we will do the train test splitting, then we will use the model. So from scikit-learn dot model selection, we will do train test splitting here. So if you don't know about test split, then I will tell you it is actually one of the component which helps you to divide the data in two sections, where one will be the training section, the other will be the testing section. So in the training section, we train the model on that data, and the testing session, and that model will be testing about the testing data. So here we will first of all create the x train, which will be the x variable for train, the y train, then we will create the x test, and then we will create the y test. And here we will use a train test split. And that, first of all, I want the x value. So the x value are all the values that are other than the traffic volume. So I will make a logic here that df dot drop. I will make a logic that take all the values that are apart from traffic volume. Df dot drop axis is equal to 1. Axis means columns, or axis means in which axis you want to drop that column. So I want to drop it from 1, which means that from the column. If I select 0, then the row will be deleted. So here we want to drop this column, because we want all these columns that are a part of this column. So we will go with the drop function, and we will go with axis is equal to 1. The second thing is y value. What should be my y value? Y value be the traffic volume. So I will actually take df traffic volume. Now what should be the test size? The test size should be 80 0.25, which means that 20% the data will be used for the testing purpose, 75% for the data will be training purpose. It depends upon you. So I will always tell you, try to go with 0.25 to zero point 0.3 if you have a good data set. Random state will be 45. Random state means shuffling. So 45 times it will be shuffled. Now let's move towards the our main problem. First of all, import the linear regression here. From linear model, import linear regression here. So we'll import the linear regression. Now we will call that class by this object, uh, linear regression here. Now we will fit it on the x train and y train. X train, y train. X train, Y train. Now if I click here on the fit, it will fit on my data. So what does it say? Found inconsistent samples with the, I think I made some sort of mistake. Yes, I remember. First of all, we need to go with the X train, X test, then we will also go with the Y train, Y test. It is actually the procedure here. Now it will work. It will work. Yes, it's fine. Now we will actually predict the values of X test, and we will store it in the Y predict. So predict lr dot predict. So we have, we will predict the x values. Now we have trained the model on x train and y train, and we will predict the x values. Now as you know, we already have the y values that are actually that are the prediction of the x values, and we also find the prediction of x values. So we will, that prediction value will be compared with the y test. If it matches, then our model is working good, we have a good accuracy, because that values have been predicted by using this model, and I already have some values that are the prediction of the x. So I will compare those values with this. So for this comparison, I will use the sklearn.matrix. I will use the R2 score. R2 score means that how fit is my data on the model. So okay, we'll pass the y predict, and we'll pass here y test. Oh, it tells me that minus 8.447. It means that our model is not good at all. That value must be between 0 and 1. It should not be less than 0, and it should not be greater than 1, because we are talking about the probability. When it comes to probability, your value between 0 and 1. So I think we should not go with the traditional algorithm. Let's try to go with the advanced. I already have code, so I don't want to waste your time here. I will copy paste the code, and I will. It's actually my model which I have performed, which I have solved yesterday. So first of all, you need to import some libraries. The first library is Grid Search CV, which enables you to check the models on different parameters. Then we will import the SVR. It is actually support vector machine algorithm. I will make soon video on each algorithm. Don't worry. The third is k nearest neighbors algorithm. The fourth is the regression algorithm. We also need to import some or two or three or more algorithms. Here's the random forest. Okay. Now, first of all, create the variables here, the models. Here I have used the logic here. I create two type of dictionaries. In that dictionary, every key value is actually the name of the model and its class. It's the name of the model and its class. And these are the parameters that will be used for the each model. So have a check on this thing. Now we will create a function here. We will create a function for model name and model in models dot items. If you know about dictionary, then you will definitely know what I am doing. Actually I am actually iterating to the model dot items to all values dot items, where the first value, which is actually the string, it will be stored with the model name, and the second value will be taken, which will be stored in the model variable. The second, the first will be stored in that model name, and the second will be stored in the model. Now what should we do? We will actually create a very we will actually create an object of grid search cv, and with the help of grid search cv we will find the best score. So grid search cv is here. Don't worry, if you don't know about these things, I will actually make a separate video on these things. First of all, we need to pass the model here. Model, what should be the model? The model is nothing but the model. I pass the model here. The model is nothing but the model's name, this thing. Now I want to pass the parameters. So for the parameters, in the params, as you know, we use the key value to access this thing. To access this thing, I need to use the that key value, and that key value is already stored in the model name. So I will use the model name here. Understand the logic. If you don't know, if you have any problem, you can also check in the give me the comment here. So then we will cv is equal to 5. Cv means cross validation, which means that our data have been shuffled from 5 times, and we will use a different I will explain you everything in a separate video, because it's actually generalized video. So to make sure, subscribe my channel. In the future video I will explain all these things, don't worry. And here we will use the scoring. Scoring means on which basis we calculate, we do all these things. So here we use the mean, negative mean squared error. Negative mean squared error. Now my model will be ready. Whenever one model will pass, it will actually calculate the, it will an object of the one model will be created. Now after creating the object, I need to pass the X train and Y train, and then I need to print the two things. Print the two things. We'll use the string comprehension here. The first thing is best model. Best model will be that, uh, you can, the model name. The model name will be nothing but that model variable. Okay. Then with best parameters, which means that with best parameters which will be used in that model, the best parameters will be gr dot best estimator, and with best score, which will be nothing but gr dot best score here. So when I click on here, it will start working. Now you will have to wait for some time. You will have to wait. If you don't want to wait, then you can what I was, actually I'm a little bit weak in English, so that's why I sometimes stuck. So you can skip that part and you can move forward. So here I will wait for some time, and then I will actually do the further processing. But before that, I want to tell you that I will make a separate video on each algorithm, and there will be, you will understand everything. And the second thing is, I don't want to skip that part because today I don't have any good screen recorder. So for this thing I want to apologize. Then and the second thing is, it will take 5 to 10 minutes. So if you want to skip the video, then you can skip the video here. So here our model training have been completed, and if first of all we get the value of minus 91, we can consider it. The second is minus 86, the third one is 10, and the fourth one is 60. So for calculating, then if you talk about the negative mean squared error, what is negative mean squared error? Negative mean squared error is nothing but the difference between the real and predicted value. So here we can say that the real and predicted value difference in here, it's quite less if we compare it with others. So we will use the Canaan's neighbor model. So we will select here the best model. In that best model, we will select the k nearest neighbors, k nearest neighbors regressor, and we will use the n neighbors as 3. Okay. Now fit it on the we will fit we will fit it on the model, which will be nothing but X train and Y train. Then we will predict our values here using this model. Best model dot predict here, and we will actually calculate with the X test values, and we will compare then these new predicted values with the predicted values we already have. Y test is actually the values we already have for the prediction. So we will actually compare these predicted values with the value we do already have. Remember, Y test are the values that are actually the answers of the X test, and we will compare then these new answers which have been calculated using this model with that value, and we will check how our question goes for. So for the R2 score, I will pass the Y predict and Y test. So here, if you are getting the accuracy of round about 84%, if you multiply with 100, 100 means, which means the accuracy, it's round about 84. So that means that our model is predicting 84%, right? And that's quite good. If you calculate some more thing, for example, some mean squared error dot matrix, import Adjusted mutual info score, adjusted rent score. Okay, we will also let's calculate the adjusted rent score. We have y predict and we have y test, and this score is 0.04. And we can also check the mean squared error here. Mean squared error must, if we mean squared error here. So if we calculate the mean squared error, we'll import it here, and then we will calculate the mean squared error, and we will pass these values y predict. As I told you, mean squared error is actually the difference between the real and predicted value. It is 51. So that means that our value is quite, it is 51 61 82, and that means that our model is ready now. Then we can use this model for the prediction. So that was all from my side. Subscribe my channel, hit the bell icon, and wait for the next video. Bye bye.